That's 60 minutes. And this is the math show on Chalk Hill Community Radio Station. Now, let me start my show this evening by giving you some data, some numbers. Year sixes, Key Stage 2. What is happening in 5 days' time? That is less than 1 week. In 5 days' time, that is in 120 hours. That is 7,200 minutes. What is going to be happening in all of the year 6 classrooms up and down the country? Yes, it's my favorite time of the year. One of my favorite times of the year. It's SATs. It's the SATs week. And why is it my favorite time of the year? It's because I know that you, year 6, you have been taught so well. You have been taught phenomenally well by your teachers, by your parents, by your TAs, by the head teacher, by everyone who is involved in your learning. So I know you're going to do good. That's all I need to know. I know that every year 6 pupil up and down the country is going to do really, really well next week. So remember, Monday the 12th of May to Thursday the 15th of May, that's in 5 days' time, 120 hours, 7,200 minutes. That is when the SATs start. SATs stands for Standard Assessment Tests, and it's a government requirement, which means that it has to be taken, that all year 6 pupils, they're the children in Key Stage 2, and they're 10 and 11 years old, they will be doing their SATs. So let me just go through the timetable with you, just so that everyone is clear and you know what's happening. On Monday, the 12th, that's in 5 days' time, 120 hours, 7,200 minutes. On Monday, the 12th, you've got your English, grammar, punctuation, and spelling. That's paper 1 and paper 2. So that's Monday, the 12th. That's the English, grammar, punctuation, and spelling. On Tuesday, you've got your English reading paper. Now, it's the same as comprehension. They give you a passage, you have to read it, and then you have to answer questions. You have to extrapolate information, pull out information, make deductions. And the good thing about Tuesday for me is that they give you a variety of genre. So it could be a poem, it could be a newspaper article, it could be some information text, it could be a letter, it could be instructions on making a cake or something. But it's something that they know, we know, young people in year 6, 10 and 11-year-olds, you will get into and you will enjoy reading and answering the questions on. So that's Tuesday. Now, Wednesday and Thursday are my favorite days, and that's why I'm beaming. On Wednesday, it's maths, and you've got paper 1 and paper 2. Now, paper 1 is the arithmetic paper, and paper 2 is what we call reasoning 1. So there are 2 reasoning papers. You've got reasoning 1 and you've got reasoning 2. And you've got 1 arithmetic paper. So paper 1 is the arithmetic. And then the second paper on Wednesday is the reasoning paper, but it's the first of the reasoning 2 papers. And then on Thursday, which is going to be sad, you've got the paper 3, which is the second reasoning paper. And then that's it. You're finished. Party time, celebrations. It's going to be absolutely amazing. So, children who are 10 and 11 in year 6 in the primary schools up and down the country, next week, Monday, is going to be an amazing week for you, because you will be able to show off how good you are, how much your parents have supported you, how amazingly brilliant the teachers have taught you, and how amazingly brilliant your brains are. I can't wait for Monday. 5 days' time, that's less than a week, 120 hours, 7,200 minutes. You can start counting down now if you really want to. So listen, if there are any parents out there, any teachers, head teachers, anyone who is involved with education and learning, call in, send a message to our young year 6s to encourage them, to support them, to wish them good luck. The number to use is 07535 644 850. 07535 644 850. Call in, wish the year 6 pupils best of luck for next week, because not that they need the luck, but it's just a nice gesture, isn't it? Because I know that the year 6s, you are going to walk it, you're going to kick it, you are just going to be the best. Let's make this year, 2025, the best year for year 6 pupils. And I know that you're going to do well, because I've taught quite a lot of you, and I've worked with a lot of your teachers. I've taught them how to teach you. So I know that you've had the best and that you're going to do well. So that's next week. Right, some tips. The vocabulary that is written, that the words that are used in the SATs, please make sure that you read lots of vocabulary that is on display in your classroom. But obviously next week it'll be covered over, so obviously there's nothing for you to read. But between now and then, there's lots of vocabulary that you must become familiar with. The one that I think is really important is the word digit. If they ask you for a digit, underline a digit, it means something that is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. A digit is not 10 and above. Please get that correct. There's a difference between digits and numbers. A digit is from 0 to 9, and a number is anything 10 and upwards. So that is really important. And when it comes to place value, it becomes even more important, because you've got your ones column, your tens, your hundreds, your thousands, your tens of thousands, hundreds of thousands, and millions. Then if you go to the right of the decimal point, you've got your tenths, your hundredths, your thousandths, and so on. This is all important vocabulary, language, words that you need to remember how to use them. Another important phrase, find the difference between. Whenever you see that, is to do with subtraction. You're taking the smaller away from the bigger. Find the difference between. When they use the word calculate, it means that you have to perform some kind of calculation, some kind of addition, subtraction, multiplication, division. And where it says show your working, you must show your working. Because by showing your working, if you get the wrong answer at the end and you put it in that little box, but you've got the workings correct, and the examiner, the person marking it, can see where you were going, they can award you half a mark or a quarter of a mark. So please, please, please remember to show your working. Right, so next Wednesday and Thursday, you know where I'll be. Yeah, you know where I'm going to be, because I'm going to be in as many schools as possible, encouraging the year 6s with their maths on Wednesday and Thursday. But I just know you're going to be amazing. So parents, teachers, inspectors, if you work at the government, call in. Wish the year 6s the best. It's just going to be such an amazing year for year 6. The number to use is 07535 644 850. And it's the Maths Show with me, Mr. Numerator, on Chalk Hill Community Radio Station. And we are giving the whole hour to our amazing, fabulous year 6s. Before I get into the show, the multiplication tables are sometimes overlooked when you get into year 6. In year 4, we do the MTC, which is the multiplication tables check. And as you know, Sovereign Comic, we've got a comic that just teaches about the MTC. But in year 5 and year 6, sometimes it lapses. Sometimes the rigor or the demand of knowing the tables is not there, but you need to know it. So what have I been doing recently over the last 2 or 3 months? I've been going through loads and loads and loads of past papers, and I have selected the top 15 multiplication questions that I know will be coming up next week. Well, when I say I know, I've got a very strong feeling. I've got about 80% strong feeling that you're going to get some of these come up, because these are the ones that have been coming up regularly, and young year 6s do not know their tables. But you must know your tables. You have to know your tables. So I'm going to read out these 15 questions. Parents, if you've got a pen handy, write these down. Make sure your children, your child, whoever it is, know these answers. So here we go. 6 times 6, which is a square number, yeah? You're multiplying the same digit by itself. So 6 times 6, 6 times 7, 6 times 8, 6 times 9, 6 times 12, 7 times 8, 7 times 9, 7 times 12, 8 times 9, 8 times 12, 12 times 12, 3 times 9, 8 times 4, 7 times 4, and 3 times 7. These are the multiplication facts. These are the multiplication questions that come up all the time within the question. So they don't just give you a question like that. They come up within the question, and especially in the arithmetic paper as well. So if you know these facts going into your SATs next week, that's in 5 days' time, okay, 120 hours, 7,200 minutes, you're going to go in with an advantage. I'm going to go through the answers. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. 6 times 12 is 72. 7 times 8 is 56. 7 times 9 is 63. 7 times 12 is 84. 8 times 9 is 72. 8 times 12 is 96. 12 times 12 is 144. 3 times 9 is 27. 8 times 4 is 32. 7 times 4 is 28. And 3 times 7 is 21. They are the multiplication facts. If you know them, if you go into your arithmetic paper on Wednesday and you're reasoning 1 and reasoning 2 on Thursday and the end of Wednesday, you are going to do amazingly well. Okay, arithmetic paper 1. So there's 3 papers, paper 1, reasoning 1 and reasoning 2. Let's start with arithmetic. Arithmetic, we are assessing, we are testing, we are making sure that you are fluent with your manipulation of number, with the operations, the 4 operations. What do we mean by the 4 operations? Addition, subtraction, multiplication, and division. Your fractions, your decimals, your percentages. This is what the arithmetic paper is testing, arithmetic. So there's a common question that I am still seeing year 6 get incorrect. And not just year 6, even some year 7s and year 8s. 0 times a number and 1 times the number. People are still getting that wrong. 0 multiplied by 937 is 0. Let me say that again. 0 multiplied by 937 or any other number, the answer is 0. 1 times 937 is the original number, which the answer is 937. So 1 times a number is the number that's the original number. 0 times a number is 0. 1 times a number is that number. So 1 times 12 is 12. 1 times 37 is 37. 1 times 1,000 is 1,000. Please don't make that mistake, because those 2 questions come up on the arithmetic paper, and that's 2 easy peasy marks. So 2 teachers, I won't call out names or schools, but 2 teachers have just texted in to say good luck to all the year 6s up and down the country. Isn't that lovely? Isn't that amazing? So there you go. Parents, teachers, more people call in. Wish the children good luck. If you want to call in and wish them luck on the radio, you can. Young people, if you want to wish your classmates good luck, you can do that. 07535 644 850. Right, addition, arithmetic. So a classic question, and when I use the word classic, it means a question that comes up regularly, is where they give you a 4-digit number. There's that word digit again, a 4-digit number like 4321, and then you have to add 2 3-digit numbers with that one 4-digit number. So you've got a 4-digit number, and then you've got a 3-digit number, and then you've got another 3-digit number, and you have to add them all together. What they're looking at is, can you arrange those 3 numbers in the correct place value column so that you get the correct answer? Okay, so addition is really important. A 4-digit number with 2 3-digit numbers. Make sure you line up your digits in the right column. So the digits in the ones column go in the ones column. The digits in the tens column go in the tens column. The digits in the hundreds column go in the hundreds column. And then the one single digit from the thousands column is in the thousands column. So line them up correctly. Do your addition. If you need to carry over to the next column, you know how to carry over. Some schools carry at the bottom underneath the line. Some schools carry above. Whatever you've been taught by your school, the policy, follow it. Another one is to do with missing numbers. So for example, a question might look like 14 plus, and then they give you an empty box, and then they give you the number 109. So 14 plus a number equals 109. How do you answer that question? You do it by inverse operations. You do it by subtracting 14 from 109, and whatever the answer is, you would write it in that empty box. Okay, so let me say it again, 14 plus, and then you've got an empty box. So in that empty box, you have to write a number, and 14 plus an empty box equals 109. How do you get the answer? You do 109, subtract 14, and then you get your answer. Right, someone has just asked me to do 109, subtract 14. Let me do it on the radio. Right, so the way that I've written it, I've got 109, 9 is in the ones column, 0 is in the tens column, and 1 is in the hundreds column. I'm going to subtract 14, so I'm going to put my 4 in the ones column. That's going to go underneath the 9. I'm going to put the 1 underneath the 0, and that's in the tens column. I'm going to have my subtraction sign. Then I'm going to have a long horizontal line to get the answer. I'm going to start from the right-hand side, which is the ones column. 9 subtract 4 is 5. I'm going to go to my next column. 0 subtract 1. You can't do that because 1 is bigger than 0. So we have to make that tens column bigger. So we have to do exchange. So I'm going to go to my hundreds column. I'm going to exchange that 1 from the hundreds column. It is now 0. And I'm going to put it into my tens column. So now I have got 10. Oh, there's another good luck from someone from Black Excellence, which is a group on the internet, and they're wishing all the year sixes best of luck. Right, so 10 subtract 1 is 9, 0 subtract 0 is 0. So the answer is 95. So 14 plus an unknown number equals 109. I solved this question. I calculated it by doing 109, subtract 14, and I got the answer of 95. So 14 plus 95 equals 109. The same thing, they might change the box around. They might have empty box plus 80 equals, for example, 396. How do you get that missing number? 396. So empty box plus 80 equals 396. So you're looking for a number that when you add 80 to it, it gives you an answer of 396. So I'm just wondering if the answer is 316, because 316 plus 80 is 396. So 396 subtract 80 will give you 316. Brilliant. Another question, 2,400 divided by 2. This is a lovely, easy 1 second answer. 1 second. You should not be having to write this down year 6. Why? Because when you are dividing by 2, you are simply halving. You are simply halving into 2 equal parts. 2,400 divided by 2, you are halving 2,400. So if you do not know what is half of 2,400, let's divide 2,400 by 10, and then let's divide it by 10 again. So we've got 24. What is half of 24? It is 12. So because we divided 2,400 by 10 and 10 again, we have to multiply our number 12 by 10 and 10 again. So 2,400 divided by 2 is 1,200. An easy question. You do not You must not have to write this down because you know what to do. This is arithmetic and you can get the answer quickly. Another question, decimal addition. What they're looking at here is, can the year 6 pupil line up that decimal number in the correct place value column? So I've got a number 7.48 plus 8.3. 7.48 plus 8.3. What you have to be able to do is know your place value columns. So in the number 7.48, the 8 is in the hundredths column. The 4 digit is in the tenths column. You've got the decimal point, and then the 7 is in the ones column. Let me say that again. In the number, the decimal number 7.48, the 7 is in the ones column. I'm going the other direction now. The 4 is in the tenths column, and the 8 is in the hundredths column. Now we've got the number 8.3. In that decimal number, the 3 is in the tenths column, and the 8 is in the ones column. So I'm going to write 8.3. I'm going to have the 8 underneath the 7 because they are both in the ones column. I'm going to have my decimal point, and I'm going to have the 3 underneath the 4 because that's in the tenths column. Now, if you want to put a 0 in the hundredths column to hold the placeholder, you can do. But that is how you do decimal addition. Remember, tonight's show, it's not about teaching how to do the decimal addition. It's about revising and explaining what to do. Then, when you come up against the question, you will know how to present your calculation, and of course, you're going to get it right. I've said this earlier. Year 6s up and down the country, you are amazing. You have been taught by amazing teachers. You have got amazing parents. You have got amazing head teachers. You've got the amazing Mr. Numerator, and we've given you the best teaching. So you're going to do well. Parents, please do not put any pressure on your year 6 pupil, your year 6 child, or teachers, because it's not about pressure. They have worked so well right from year 3 to year 6. What they know now. It's as simple as that. So let them show off. Whatever they get is what they get. It doesn't mean that they can't start a secondary school. It doesn't mean that they're at a disadvantage. Whatever they get, they get. Let's encourage them and let's just fill them with confidence and knowledge. Empty box equals 240 divided by 8. Right, so what that is asking is, what is 240 divided by 8? And whatever the answer is, you put it in the empty box. Right, what do I know? I know that there's a connection between the number 8 and the number 240. But to make it even easier, I'm going to divide 240 by 10 to get the number 24. What is the connection between 24 and 8? Well, I know that 3 times 8 equals 24. And 24 multiplied by 10 is 240. So if I know that 24 divided by 8 is 3, I know that 240 divided by 8 is 30. So in that empty box would go 30, because 30 equals 240 divided by 8. The empty boxes, they love to give those questions, but they're really, really easy. We're doing really well this afternoon with all of these arithmetic questions. Right, the next one, I know some of you are going to say to me, bid maths. I know a lot of you, when you hear me talk about bid maths, you go, oh, no, not again. Right, bid maths, it comes up. Here's my question. 6 plus 4 divided by 2. 6 plus 4 divided by 2. Right, let's do it this way and let's see what happens. 6 plus 4 is 10. 10 divided by 2 is 5. Is that the right answer? No, because big maths stands for brackets, indices, which are square numbers, division, multiplication, addition, and subtraction. So this is the order of operations. That's telling us division comes before addition. So in the question, 6 plus 4 divided by 2, we have to do the division part of it, which is 4 divided by 2 is 2. Then we do addition next. 2 plus 2 is 4. So the answer to the question 6 plus 4 divided by 2, it is not 5. The answer is 4. Why is it not 5? Because 6 plus 4 is 10. 10 divided by 2 is 5, but that is not following BIDMAS. BIDMAS dictates that we do 4 divided by 2 first, which is 2, and 6 plus 2. Oh, I've made a mistake there. 6 plus 2 is 8. So the answer is 8, okay? So let me say it again. The answer is not 5. So we do not do 6 plus 4, which is 10 divided by 2, which is 5. We do 4 divided by 2, which is 2. 2 plus 6 is 8. So the answer is 8. Even Mr. Numerator can get something wrong. Charlie has sent something. Okay, we'll come back to that shortly. Here's another easy peasy lemon squeezy question. 7 times 10 times 12. 7 times 10 times 12. Now, you've got the same operation, multiplication. So it does not matter the order in which you do this calculation. So the question is written 7 times 10 times 12, but I'm going to do it using my knowledge and my confidence. I'm going to do 7 times 12, which is 84. 84 times 10 is 840. For me, it just makes it easier because I know 7 times 12, and it's easy for me to multiply a number by 10 to get the answer. You can do 7 times 10, which is 70, and then times that by 12. You get exactly the same answer, but we're looking at efficiency here. We're looking at what strategies and skills can you use to make the time quicker and more productive for you. Fractions. Oh, I've missed that long division. Remember your long division. Long division means you are dividing a 3-digit number by a 2-digit number upwards. Short division is where you're dividing a 2 or 3-digit number upwards by a single digit. And that is really, really important. Okay, so that's the difference between long division and short division. Short division, I know they call the bus stop. I like the 2 different terms, long division and short division. You use the bus stop to get the short division answer. Brilliant. Fractions, as you know, is my favorite topic in maths, fractions. So you need to be able to add fractions that have got the same denominator, but that's easy, and then add fractions that have got different denominators. So for example, you've got 4/5 plus 2/3. You need to know about the common denominator. You need to know about making the denominators look the same, how to do all of that. So please remember what to do. Remember the strategy, the method you've been taught by your amazing teacher. So 4/5 plus 2/3, because they've got different denominators, we have to make the denominators the same. I know my multiplication tables. 3 times 5 is 15. So 15 is going to become my common denominator. How many 5s are there in 15 is 3. 3 times 4, which is my numerator, is 12. How many 3s are there in 15? That's 5. 5 times 2 is 10. 10 plus 12 is 22 over 15. That is what we call an improper fraction. How do we turn an improper fraction into a mixed number? How many times can 15 divide into 22? That's 1, and there's 7 left over. So the answer is 1 and 7 over 15. But hey, I've rushed through that example because you know it, and if you don't know it, then you can find out from your teacher tomorrow at school. Adding fractions with different denominators, the same thing with adding, subtracting, and multiplying with mixed numbers, and so on and so on. And yeah, this is really, really important that you know about the 4 rules with fractions. Fractions of an amount, a quantity, for example, 3/5 of 30. The way that I would teach it is I'll have a rectangular bar and I would divide it into 5 equal parts. Why? Because my denominator is 5. 1, 2, 3, 4, 5. The whole rectangular bar is worth 30 because we're doing 3/5 of 30. So the whole rectangular bar is worth 30. It's been divided into 5 equal parts. 30 divided by 5 is 6. and I want 3 of them. So 3 lots of 6s are 18. So 3/5 of 30, the answer is 18. So that's fractions of a whole amount. When you're dividing fractions by an integer, please remember an integer is a whole number. An integer cannot be a decimal or a fraction. So for example, if I have got 1/8 divided by 2, that is dividing a fraction by a unit fraction by an integer. And all I'm going to do there is I'm going to turn my integer into a fraction. I'm going to put a horizontal line underneath the 2 and put the number 1. So I've got 1/8 divided by 2 over 1. I can then do my keep, change, and flip, and I can get my correct answer. 15% of 3,200, the way that I would teach it and the way that I would do it, there's different ways of doing it. I know I was in a school this morning and the teacher was teaching it 15 divided by 100 because the word percentage means 100, multiplied by 3,200, and then you can simplify and you can do all the things you have to do. You can do it that way. The way that I would do it, the efficient way, is I would break up my 15% into 10% and 5%. Why? Because I know half of 10 is 5, so I've got something to help me. I would do 10% of 3,200, which is 320. I would then do 5% of that. So half of 320 is 160, and then add them together and get the answer of 480. Different ways of getting the same answer. But as I always say to young people, please follow what your amazing teachers have taught you and follow the strategy, the method that you've been taught, because now I'm not going to be here to teach something new and then confuse anyone. You do what you know best. So very interesting. Right. Okay. Here we go. So once again, just getting some nice comments from different people. Wow. Okay. So I've had a nice comment from a teacher in a school in Edmonton. You know who you are. And then I've had something from Timmy, who's my son, who always wishes the year 6s the best of luck. And it's just so nice to be able to read out good luck messages to our amazing year 6 teachers. And that's because of your class teacher. Another lovely question that I like is 99% of a number. That's so easy because 99% is 1% away from that number. So all you need to do is find 1% of the number you're finding, and then that's it. Take it away from the amount. So 99% of 600. Right. What do I know? I know that 1% of 600 is 6. So I'm going to do 600, subtract 6, and that's going to give me 594. That's the straightforward way to do it. If you're going to do 1% of the number, then another question that I use is 2% of 3,000. Work out 1% and then double it, and then you've got your answer. So that's the arithmetic paper. I've given you what you need to know year 6. Now, we're going to have a really short ad break. We have to have the ad break because we're promoting. And then when we come back, we're going to look at reasoning 1, which is paper 2 out of 3. And then we're going to look at reasoning 2, which is paper 3 of 3. Okay, so it's not going to be too long. Don't go too far, and see you very shortly.
Hey Londoners, are you ready to start your
to www.sovereigncomics.co.uk and get your latest issue of Numerator's Maths comic book series today. You are now tuned into the Mr. Numerator Show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station. Let's get mathematical.
Hello and welcome back to part 2 of the Math Show with me, Mr. Numerator, on Chalk Hill Community Radio Station. There's someone who's in the studio, and you know that someone is always in the studio because he's the main person behind Sovereign Comics, alongside Paul and myself, but he's the main person, and it's Dean, and he wants to say something to all the Year 6s up and down the country. Dean.
Hello, Year 6s. This is Dean from Sovereign Comics, and I'd like to say from myself and everyone else at Sovereign Comics, good luck next week for your SATs. Is it?
Yeah, on Thursday for the maths.
And do really well.
Of course. Thank you very much indeed, Dean. So that was Dean wishing everyone, and I think what Dean said, that which is so important, which is really important, you must not panic. I know it's easy for Dean and myself to say that because we've been through it, but we mean it, because the minute you start panicking, you close your brain panics, and then you close off the thought channels. So just go in. Whatever you know will be enough, and just do your best. But more importantly, enjoy the SATs. You know, whatever question you answer, you get it right, brilliant. You get it wrong, brilliant. It's not the end of the world, and that's what Dean just said. And remember, your parents, your families will be happy with whatever you get. Whether you get 1 or 100, they will be happy with you because you've done your best. Right. Okay. So part 2 of the math show. We're going to start off with reasoning paper 1. So there are 2 reasoning papers. There's paper 1 and there's paper 2. We've been through the arithmetic paper. So there are 3 papers for Key Stage 2 Math SATs. We've been through arithmetic, which we call paper 1. We're now going to do paper 2, which is reasoning 1. I know it just sounds weird because, you know, people have to make things difficult for our young people. But anyway, it's reasoning 1. And yeah, let's go through some questions. I've made some questions up. I've taken some questions from papers, but what I'm doing, I'm just giving you a run through of the topics that will be coming up next week. Remember, that's 5 days time. That is 120 hours, and that's 7,200 minutes. I was going to go into seconds, but I won't because that'd be too much. Right. So a lovely classic question. They give you a question like this. I've got 210. And they give you an arrow pointing towards the right, and then they give you another number, let's say it's 180. So you've got the number 210, you've got an arrow pointing from 210 to the right to another number, which is 180. And then you have to work out how much more or less is 210 than the number 180. So 210 is 30 more than 180. So you would write 30 more than 100. 210 is 30 more than 180. So another easy question that you can do it. Right, here we go. Another one of my favorite questions. There are 300 sheets of paper in a pack of 300 sheets of paper. Now, you have got 4 children, and each of those 4 children takes 8 sheets each. So you've got 300 sheets of paper. So I would underline 300 sheets. And then you've got 4 children. I've underlined the number 4, and they take 8 sheets each. So if 4 children take 8 sheets of paper each, that is 4 multiplied by 8. I told you the multiplication tables, you need to know them. Right, 4 times 8 is 32. So what do you do with that number 32? Because the question is, how much paper is left in the pack? So because we know that 32 pieces of paper have been taken, our calculation now looks like 300 subtract 32. Where did the 32 come from? Because there were 4 children, and each of those 4 children took 8 sheets of paper each. 4 multiplied by 8 is 32. And the question is asking us how much paper is left in the pack. So my calculation is 300 subtract 32. I'm going to do it using subtraction. 0 subtract 2 I can't do. 0 subtract 2 I can't do. I'm going to go to my hundreds column. I'm going to exchange 100. I'm going to put it there for the 10. I'm going to exchange that 10 to make it 9 and give it to my ones column. So now I've got 10 subtract 2 is 8. 9 subtract 3 is 6, and 2 subtract 0 is 2. So that means there are 268 sheets of paper left in the pack. Lovely question, straightforward, but it's asking you to show your working and your calculation, because they want to make sure that you know how to exchange. Please don't use the word borrow, because when you borrow something, you have to give it back, and you don't give it back. We are exchanging, we are regrouping, we are making particular columns bigger. So that is what that's looking at. Please make sure you know how to read and interpret and maybe complete some bar charts, okay? Bar graphs and bar charts are exactly the same thing. But remember, this is where some year 6s have been caught out over the years. They can give you a vertical bar chart, but they can also give you horizontal bar charts. It's the same thing, but it's obviously been changed. It's a different direction. You've got vertical going up, and you've got horizontal bar charts going across. Just make sure you've got your scale. You know your y-axis, you know your x-axis. Look at the scale, look at the increments. That means, how is the scale going up? Is it going up in 5s, in 2s, in 10s, in 50s or 100s? Just make sure you understand about the scale. Another question that they like to ask is, how much warmer is one country than another? So you have to use the chart. You have to look for 2 countries. One country will be warmer than another. How do you work out which country is warmer? You do the subtraction and you get your answer. Or it could be find the difference in temperature between 2 countries and so on. Matching a fraction to its shaded equivalent. So they give you a series of rectangles with different pieces. So you might have a rectangle that's got 10 equal parts. And then 2 have been shaded. So 2 out of that 10 have been shaded. So the fraction is 2/10, but that's not the final answer, because 2/10 can be simplified to 1/5. Now that is the correct answer, so be careful. Time, converting minutes to hours and minutes. So if you've got 340 minutes, how many hours is equivalent to 340 minutes, and how many minutes are left over? So what facts do we know? I know that there are 60 minutes in 1 hour. So how many lots of 60s are there in 30? Well, I can count in 60s. 60, 120, 180, 240, 300. So that's 5 lots of 60s. That's 5 hours. And then there's 40 minutes left over. So the answer would be 5 hours and 40 minutes. Remember the difference between multiples, factors, prime numbers, and so on, because they ask you to, they might say circle, which means you draw a circle around the factors of 20, for example, and that's what you would do. Multiples, they might say draw circles around 3 multiples of 7 from a given amount, or they might say identify and circle 3 prime numbers, and their prime number is a number that can only be divided by itself and 1. So yeah, I'm this math show on Chalker Community Radio Station, it's just giving you so much, okay? It is just giving you so much. There's always questions to do with money and shopping. There's another congratulations and wishing year 6s best of luck from a head teacher. So please make sure you know about your shopping and about money and about prices, just so that you are able to calculate shopping and money, and then you can make sense of it. Really important. And it's all about what we do, and it's all about what you should know, and it's all about what we are teaching you in the classroom. Roman numerals, if there is a question, it's only going to be one question. it might be one question with 2 parts, but it's not going to be 3 or 4 parts. And Roman numerals, what do you need to know? You've got I is worth 1, V is worth 5, X is worth 10, L is worth 50, C is 100, D is 500, and M is 1000. I'm going to repeat that again. I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. Just remember, if you've got Roman numerals VI, okay, a VI, that means you are adding, because you are adding a bigger number with a smaller. So we're going to the right. So V plus I, V plus 1 is 6. If it's IV, you're going from smaller to bigger, which means you have to subtract. It's 5 subtract 1, which is 4. So VI is, we're going from a big number. 5 is bigger than I, which is 1. So VI is 5 plus 1, which is 6. When you're going from small to big, that's what I and V. It's what is subtraction, so it is 4. Just remember your Roman numerals. Think about remembering your rounding. Different types of triangles. We've got isosceles, 2 sides are the same, 2 angles are the same. We've got equilateral, where you've got 3 angles and 3 sides the same. You've got scaling, where you've got no sides are the same and no angles are the same. And then you have got a right angle, which has got a 90-degree right angle. So they're the different types of triangles. Remember your angle knowledge. Angles on a straight line, 180. Opposite angles are the same. Angles in a triangle, 180. And angles in a quadrilateral is 360. These are what we call interior angles. That is what you'll be tested on. So just remember your angle work. So that was reasoning paper 1, which is paper 2 out of 3. So let's turn our attention now to paper reasoning 2, which is paper 3. Okay, there's 3 papers, and I've just written down some questions. I'm just looking at the clock because I know that the time is going really, really quickly, and I just wish. Oh, Sovereign Comics have just tagged me in the reel. Thank you, Dean. Because I know we're running out of time, so I just want to make sure that that we get through as much as we can. Right, reading different types of diagrams. Remember, in math, we teach you about a Carroll diagram, a Venn diagram, and a tri-Venn diagram. Do you know what, Dean? I've just had an idea. For next year, we have to do a comic for the Key Stage 2 SATs. With all this information, oh my gosh, that will be a Dean MTC, and then the year 6. That would be amazing. So we'll talk about it later.
Good idea.
Yeah. Okay. So Dean, what did you say?
Very good idea.
It would be an amazing idea, because then we could get the comic out in time. Let's say we're in May now. If we got the comic out in February or January, then all the information that I've gone through, I'm going to keep all of these pieces of paper, give them over to you. This is it. These are the answers, Dean. Okay. So we'll do that. Yeah. Okay. Thank you, Dean. So that's a good idea. Right. So a Carroll diagram is where you got like a rectangle and you've got 4 parts. Okay. Then you've got 4 attributes, 2 at the top and 2 at the side. And then you've got a Venn diagram where you've got 2 circles and they're joined together in the middle. And then you've got a tri-Venn diagram where you've got 3 circles and they're all connected, 2 connected in the middle, and then the third one is connected to all 3. So just remember how to read and interpret a tri-Venn diagram. Remember how to use number lines. So sometimes they give you a sequence. They might say 12, 15, 18, and then they might say, what are the next 3 numbers in this pattern, in this sequence? You know that you're adding 3 each time. When you get into year 7, 8, and 9, you'll be taught about the nth term. This is where it starts. A very big area for me that I do see year 6s weak on is a capacity, volume, and measure and length. Remember, there are 1,000 milliliters in a liter. There are 1,000 milliliters, because the word milli is 1,000. Like in Roman numerals, meal is 1,000. Okay, right, here we go. That's the connection. So there are 1,000 milliliters in a liter. There are 500 milliliters in half a liter. There are 250 milliliters in a quarter of a liter. So all I'm doing there, I'm combining fractions with capacity. Then we've got centimeters and meters. There are 100 centimeters in a meter. And then you've got 1,000 meters equal a kilometer. Right. What does 1 meter look like? Right. Okay. Most doors in your houses are always 2 meters in height. So all doors are 2 meters in height. That's a fact. That's the way doors were made and created. Okay. So doors are 2 meters. Now, when I walk through a door, I don't have to bend my head, but obviously my head is quite close to the top of the door. So I know that I am shorter than 2 meters. So 2 meters is the same as 200 centimeters. An average year 5, year 6 pupil is about 1 meter 30. That's sort of, roughly. That's 130 centimeters. So the meter ruler plus 30 centimeters rule, that's the usual rough height of a typical year 5, year 6 pupil. Then you've got multiplying by 10, 100, and 1,000. And guess what? Sovereign Comics and Mr. Numerator, we've got a book all about multiplying by 10, 100, and 1,000. So I'm now thinking, I'm going to think aloud, Dean. I'm going to ask Dean a question. Dean, for next year, I think what we could do is the comics that we've got so far, equivalent fractions, angles, multiplying by 10, 100, and 1,000, and then the SATs preparation. Can we put them all into one booklet?
Because that's quite possible, yeah.
Yeah, because then a child has got all the information at hand. So that's something we can work on, yeah?
Yeah.
Fantastic. I've got to go through, Dean, otherwise I've been in a lot of trouble. Right, recognizing money. The way that I always teach recognizing money is that I sort money into silver and non-silver, and then I sort money into big and small. So remember, our 5p coin is silver and it's our smallest coin. So you can sort the money that we use. But what you need to remember is we use 12 different amounts of money. We use 12 different amounts of money. I'm going to go through them now. We use 1p, 2p, 5p, 10p, 20p, 50p, £1, £2, £5, £10 is paper money. So is £5, but I have got a £5 coin, but we won't go there. We've got £20 and we've got £50. So let me say that again. 1p, 2p, 5p, 10p, 20p, 50p. They're all the coins. Then we've got a £1 coin, £2 coin, £5 paper money, £10 paper money, £20 paper money, and £50 paper money. Now, if we add up each of those amounts of money, you would have £88 and 88 pence. So just remember the money that we use. Remember coordinates. You've got your y-axis that goes up and your horizontal axis that goes across, which is the x-axis. Remember how to plot coordinates. You've got your little cross and it might say put the point 4, 6. So remember, we do x before y. In the alphabet, x comes before y. So if you've got a coordinate and you've got 5 and 7, the 5 is the x, the 7 is the y. So you'd go along 5 and then go up 7 and then put a little cross there. That is the basic coordinates. Remember your 2D shapes and your 3D shapes. And then I'm going to go into mode, mean, median, and range, which is to do with averages and statistics and data. Mode is the most popular. Mean is the average, where you add up all of your results and you divide by the total number of results. Median is where you put your data into ascending order and then you find the middle number or the middle digit. If you've got 2 in the middle, you add them together, then you divide by 2 until you find that one median. And then the range is the difference between the smallest and the biggest. Pie charts, as you know, is another one of my favorites, okay? Now, what they like to do is give you 2 pie charts to compare. So let's start from the beginning. When you're looking at pie charts, a pie chart is divided into sections, but we do not call them sections, we call them sectors. S-E-C-T-O-R-S, they are sectors. And the common sectors that you will be given are half, quarter, third, eighth, and a fifth. So just remember what those sectors look like. Half is half of the pie. A quarter is a quarter of the pie. So there's 4 equal parts. A half, there's 2 equal parts. A third, excuse me, where you've got 3 parts. And so that looks like a third. An eighth is half of a quarter. So if you've got your quarter, half of a quarter is an eighth. And then your fifth is where you've got 5 equal parts and you want one of them. So they are the sectors that are most common. When they ask you to compare pie charts, I've got 2 pie charts drawn here, 2 equal size circles. My first pie chart is worth 100 girls, and my second pie chart is worth 60 boys. They are 2 pie charts. But what I've done is that I have got two quarter sectors. So I've got a sector, that's a quarter for my 100 pie chart, and I've got a quarter sector for my 60 boys. And the question is, which of those sectors will give you more children? Right. So if you've got a pie chart that's worth 100 girls, and you've got a quarter of 100 is 25 girls. Now, if you've got another pie chart and you've got a quarter and that's worth 60 boys, a quarter of 60 is 15 boys. So the quarter for the girls is worth more than the quarter for the boys. And that's the easy way, Dean's looking at me, and that's the easy way to remember about pie charts, okay? So remember what to look for in pie charts, and just remember to make the maths come alive. Right, listen, very quickly, I don't like this part of the show because it means that we're coming to the end. So just remember, next week, 5 days' time, 120 hours, 7,200 minutes. The Key Stage 2 SAT starts for year 6, and that is when you're 10 and 11. On Monday, it's the English grammar, punctuation and spelling. It's paper 1 and paper 2. On Tuesday, the 13th, that's the English reading paper. That's to do with comprehension. They might give you a poem, a newspaper article, information text. It might be about lions or spiders. They might give you a letter. They might give you a set of instructions. It's going to be interesting to see what they actually do give you this year. And then you have to answer questions on it. You have to extrapolate information, which means pull out information. You have to make deductions. You have to look for this and that. Wednesday, good old Wednesday, you've got maths. And Thursday, you've got maths. On Wednesday, you've got paper 1, which is the arithmetic. And then you've got paper 2, which is reasoning 1. And then on Thursday, you've got the third paper for the maths, which is reasoning 2. And then that's it. You can go on holiday. No, don't go on holiday, please. I'm just joking there, okay? Parents, I do not mean that. I'm just being a bit flippant, which means I'm getting a bit excited with what I'm saying on the radio. No, you've got a long way to go to the end of term, yeah? But listen, I'm wishing you all the best. Dean's wished you all the best. Just remember, read the question, underline important key words and key facts. I know that you're going to do it year 6. There's no reason why any year 6 is not going to do well. How do I know? Because you have been taught by amazing teachers. You've been taught by people like myself, Mr. Numerator. You've been taught by people like Dean and Paul with the comics, because they are teachers as well. They are teaching you through the comic. So we're all teaching you. You will do well. Head teachers, parents, families, inspectors, government ministers, let's wish all of our year 6 pupils the best. Next week, we're going to be getting the year 4s ready for their MTC. And then we're going to be looking at the GCSE maths pupils as well, because they've got their maths coming up soon as well. So we're doing it in stages. GCSE maths, MTC, the maths show, it all happens. Have a great evening, a great weekend. Year 6s have a lot of rest, eat lots of food, the correct type of food, okay? And then I wish you all the best for next week. And yeah, if you want to call in next Wednesday and let me know how you got on, you can do so. 07535 644 857. Have a great evening, a great weekend. Thank you from all of us on Chalker Community Radio Station. Thank you from Dean and myself on Sovereign Comics. It's Mr. Numerator. See you again soon, and thank you.